Okay, quick review of what we did yesterday was complicated combinations questions. So the order doesn't matter, but they're not easy. These are the kind where if I said, for instance, you had 6 defective TVs out of a group of 1,000, if you went and bought 2 TVs, what's the probability you're going to get one of them? I'm going to say the data one more time. 6 out of 1,000 TVs in the warehouse are defective. You go buy 2 TVs, what's the probability you get one of the defective ones? I'm going to pause for a second while I give that a try. All right, totals go on the bottom. There were 1,000 TVs, and we bought 2 of them. So always start with the bottom because it's the simplest thing, and it's, I don't know, it gets kind of the total together, so you start realizing, okay, now the smaller groups, they go on top, the subgroups. This is defective. This is not. You could rearrange those, of course, but what's the defective ones? How many defective are there? That's what you always ask for this spot. Like, how many TVs are there? How many do we want? How many are defective? There were 6 defective ones. How many are we talking about getting? 1. 1 defective one. In case you missed that, we're buying 2 TVs. One of them's defective. Okay. So then, how many not defective TVs are there? Do you remember how this and this have to add up to this? All right, so 900 and what? 994. And now, this plus this will equal that. Yay. Can I be done? No, I'm really close though. I have this and this need to equal this, and so that was another 1. Raise your hand if you had that before I did. Okay, now I helped a lot with that one. I'm going to give you one more that's like that. Okay. I have been fishing many, many, many times, and I've only heard of this once. A guy caught a northern type of fish that was purple. It was purple in color. And so let's say that out of all the northern pike swimming around in all the lakes that I've ever fished on, let's say that there was, okay, let's make it on not all the lakes I've ever fished on. Let's say that I'm fishing on this body of water and there's 200 northern in there, but there's only 1 purple one. Actually, no, that's going to be too easy to do. 2 purple ones. Sorry, there's 2 purple ones. If I catch 5 fish, what's the probability I will get one? 1 out of the 5. I'll say the data again. There's a couple hundred fish swimming around down there, northern pike, and 2 of them are purple. If I catch 5 fish, 5 northern pike, then what's the probability I get 1 of the purple ones? So where did I say to start? Bottom or top? The bottom. And the bottom is the totals. So there were 200 fish. Choosing out how many are my total taking out of the lake? 5. And then I go up to the subgroups. And then there's what kind of northerns? Blonde and dark-haired? No, there's purple and not purple. And how many purple ones? 2. How many do I want to get? 1. Did I ever say or? If so, there'd be a plus in there. But I said and, so there's a times in there. And then I would go, how many of the other kind are there? This is the total. 198. And then how many of those do I want to get? 4, because then this plus this will equal this. That plus that will equal that. Yay. All right, now I'll make it slightly more complicated. What's the probability? This was, by the way, this was the probability of catching one of those northerns, right? Let's leave that on your screen and see if you know what to do if I change the problem to what's the probability to catch one of them or both of them? One of the purple ones or both of them? Pause for a second while you figure out how to use that or thing. Or means add, so I say plus. Now I have two choices. I could just do the whole bottom exactly the same as before. Or do you get, since they have a common denominator, I could just do the adding on the top, put them all together into one fraction. See what I'm saying? So again, I'm going to just show you how it's a completely separate question. It's either you get one or you get both. And if you get both, you get 2C2 times 198 C, sorry, 2C2, 198 C, I need to catch 5 fish, so 3. There we go. Now, I know a lot of you just put this on the top and you said plus that, and you didn't have the denominator. Is that okay? Yeah, you don't like multiply the denominators when you add things, so. Yeah. All right, so I tried to show you how this could be two separate fractions, or since you're adding them together and they have a common denominator, I don't need this part on the bottom. I could just say one big numerator and a plus where it says or. Does that make sense? All right, so ors you add. Let's do one more and it's going to be a little simpler. Not so many things. All right, let's say that there's this bowl full of Skittles out on the table, and there's a red one, a couple red ones. Let's say there's 3 green ones and a blue one. Now there's a total of 6 Skittles. You reach in, you grab 3 Skittles. What's the probability that you get 1 red and 2 green? Okay. Remember, start at the bottom. What's the totals? How many Skittles are there? 6. How many am I taking out? 3. And then I do subgroups. There's actually 3 subgroups this time. There's blue, red, and green. Blue, red, and green. There's a C for each of them. Okay? I never said or, so now they're all multiplied. And then how many blue ones are there? 1. And I'm going to get how many blue ones? You sure I'm going to get 0? Okay, yeah, you're right. You're right. Sorry. I just want to make sure that our total was 3. And you're right, because I said 1 red out of 2. And last but not least, the green. I'll do that in green. There were 3 to choose from, and I want 2. Check the balance. 0 plus 1 plus 2 equals 3. Worked. And I'll make this in triangles. The 1 and the 2 and the 3 makes a total of 6. And the red triangle's all balanced too, so yay, it worked. Raise your hand if you had that one right. Okay, now we're just going to make that into an and question. Slightly different. You're right, I mean an or. What's the probability you get a red and a green or a red and a blue? You can do them as completely different problems if you want to. Red and a green. And this is trickier than you might think because I've got a total of 3 Skittles you're grabbing. One red, one green, or one red, one blue. These even are tough for math teachers. I've got a friend who's a math teacher, has been for a long time, teaches high-level math, and they won't even try probability questions. Seriously, they're really good at math. They won't do probability. Because they're like, that stuff confuses me so much. Okay? Yeah. Yeah. Yes. That's the appropriate response. Hit them with the probability, like, you know. So, what's the probability that you're going to answer this probability question? Anyway. Okay. Probability of one red and one green. Now, if there's only one red and only one green, and you got 3 marbles, what has to be true that I didn't say, but it has to be true? Then I'd only have 2 marbles if I had 0 of the other ones. Or sorry, Skittles. If I'm going to have 3 Skittles, you better have 3 Skittles. So this is, I'm grabbing 3 Skittles out of 6, so that's 6C3. You can't just do this. I know some of you did. I got 2 red ones and I want 1. And I have, as far as green ones, 3 green ones and I want 1. Why not? Well, it doesn't work in a lot of ways. That plus that doesn't equal that. Know what I mean? So what can you say about blue ones then? They have to have a blue one. It's the only way that's going to work. Because why? How do I know that? Because look, now, that's the only way I can make that add up to 6. And then how many of them do you have to have? Well, there's only one way to do that. The arrowed ones here, that, and that have to add up to 3. So that's how I knew that had to be a 1 right there. Okay. Now, it says or. Or means add. And then I do the same kind of thing again. I'd make my total. And the nice part about making them into separate questions is you can still do that balancing thing. And there's red ones, there's 2 and I want 1, times 1 blue one, there's 1 and I want 1. But again, hopefully you'd be smart enough to go, that and that don't make up 6. So therefore there must be one last piece, 3 of the green ones. And it never said this, but it must be true that I got 1 of them, because 1 plus 1 plus 1 will equal 3. So there we go. Now, could you put this all into one big fraction? Yes, you could, because the denominators are the same. You could kind of push them together, and the tops would get added, and the bottom would be 6C3. Okay. Now, new stuff. Completely new. This next thing is called binomial probability. What does bi mean? 2. So a bicycle has 2 tires. In binomials, you have 2 things that can happen. This cannot work when you have 3 possible outcomes. Like, if I throw this marker and it could be closest to any one of you, that's not 2 different outcomes. That's like, I don't know, looks like there's about 25 people today. It's like 25 different outcomes. All right, so this only works if there's 2 outcomes. But that actually is a ton of things in the real world. Like, you caught a fish or you didn't catch a fish. You shot a basket and you either made it or you missed. You shot at the hoop. Okay, and you either make it or you don't. There's no like, oh, you kind of made it. No, no. I know in the real world there's a lot of gray areas. What if you shoot the ball and it gets stuck up there? Well, you didn't really miss, but you haven't made it yet. I know. You can always make an exception for everything, but we're going to assume some basic things like if you're shooting in soccer and you're trying to kick it in and you kick it and it either goes in or it doesn't. You either score or you don't. All right. So here is a typical one. Let's see how quickly you can catch on. Let's say that, okay, who in here plays soccer? Actually knows a little bit about soccer. All right. Can you tell me if there's penalty kicks, what percentage, if you had to make your best estimate, what percentage of people make their penalty kicks?
I'd say like 80.
All right. So let's go with that. 80% making the penalty kick, and I know there's a million ways they can happen. What if the penalty kick's from far away, then there's a less chance, and blah, blah, blah. But he's just giving his best guess, and we're going with it. Now watch what I do. If it's 80% chance that you're going to make it, right away I know there's a what chance you're not going to make it? 20, and that's not. Then, here's an example of a problem, and I'll show you how to fill in the rest. So there's this soccer game, and at the end, they end up having 2 penalty kicks. What's the probability that they make one and they miss one? I've never done anything like this before. It's actually could be kind of like one of those CC over C questions, but let me show you how it goes. This little formula is a C at the beginning. And how many do you think I'm going to put that it's out of? 2. And then how many did they make? Okay, 2C1. And then if they made 1, I'm going to put it to the power of 1 here. And if they missed 1, I'm going to put a power of 1 there. And if you multiply that all out, that's your answer. That's a pretty cool, quick formula. If you have an 80% chance of making it, and you want to see about, well, I took 2 shots and made 1 of them. That's a pretty common thing that could happen in a game. Make 1, miss 1. What's the probability that would happen? All right. Somebody with fast fingers, what'd you get? 3-2, even? Anybody verify 0.32? Okay, a bunch of people are agreeing that's 0.32. So there's only a 32% chance that would happen. What's the probability that won't happen then? 68, and you automatically did 1 minus that. Remember that, because when the question gets harder and it's the same basic idea, you take 1 minus what you don't want. Okay, so now I want to do the same exact formula, except I want to use it to figure out what's the probability they're going to make 2 out of 2. So right above it, if you have to, move it down, snip it, move it somehow. You don't want to do this in the wrong order. We want 2C2 above it. I'll show you why in a minute, because we'll have a nice list of all 3. Stay focused. Some of you are going into a food coma because it's after lunch. Stay with me. All right, 2C2. That means you make both of them. And that means, how many of you are already doing this? 0.80 to the 2. Raise your hand if you had that one right. Awesome. Now, do I have to have this? Well, yes and no. It makes it nice and neat and, like, cleans it up. But technically, what's that equal to? 1, and so I don't really have to have it. Now, then what's the final answer? Well, it really comes down to this is equal to 1. This part's equal to 1. If you have 2 things and you choose out both of them, there's only one way to do that. Okay, and then it's just really 0.8 times, no, not times 2, 0.8 to the second. 0.8 times 0.8. I can do that in my head. 8 times 8, 64. 0.64. Now, does it make sense that it's more likely that that would happen? Think about that. I mean, they're pretty good at kicking these things. Isn't it more likely they make both of them? Yeah, so it makes sense. Wait a minute, that only adds up to 96%. There's a 4% chance of what then? They don't make any, and that's the one that goes on the bottom. Everybody write that one out. 2C0, 0.80 to the 0, 0.20 to the 2, and then that's how we get 0.04. Did you notice, though, that I didn't even have to do that calculation? I knew what the last number had to be. Okay, so this next answer is kind of like that. This next answer, even though you might be tempted to use these guys, don't, because you don't. Look at all the work you have to do to get those. Isn't that a lot of putting into the calculator? This next answer I'm about to give, the question, the answer, you won't need to have the top part. What's the probability that the person would make at least one? Well, typically people go and figure out one, and then they realize, oh wait, at least one means 1 or 2, right? And so then they go back and calculate all of that. But what would the little bit smarter kid have done right off the bat? They would have done 1 minus the 0.04. Do you see what I mean? You only have to do one of them instead of two of them. And this one's faster to do because that's equal to 1, that's equal to 1. So it's just 0.2 to the second. All right. So this comes down to not. If you made at least one, you did not do that. And not something means 1 minus it. If I said it's going to rain tomorrow, 20% chance it's going to rain tomorrow, well, what's the chance it's not going to rain? 80, and you just did that in your head, but really what you did is 1 minus the 0.2. 1 minus the other probability. Okay, so I'm going to do that again, and you'll see on this next question that you can do it the slow way, which is find out this, add them together, or you can do it the fast way, and you're going to like the fast way a lot better. Okay, same kind of question, except we'll make it about basketball this time. And let's say this time the kid is a 75% free throw shooter, and he gets 5 shots. What's the probability he'll make at least one? I'm going to say it one more time. He's a basketball player that shoots 75% typically. That's his normal free throw percentage. He gets 5 shots. What's the probability he'll make at least one? Common mistake answer? 5, choose 1. 0.25. And you got 5 misses and 1 make. So that would be that'd be 1 here and a 4. Oh, it's 5 shots. So it'll be 4 misses and 1 make. There we go. That's the wrong answer. Because that's the probability of getting 1. And then you'd have to do or probability of 2, or probability of 3, or probability of 4. So hopefully you got the idea here. Some kids actually do that. They figure out all of those and add them up just to avoid this other way, which would have been, I'm going to say it one last time, 75% free throw shooter. He gets 5 shots. What's the probability he makes at least one of them? Then you're going to figure out the probability he makes none of them. Right? Mr. L, tell me what to do. Let's see what. Oh, sorry. GL.
You could do 5C0.
5C0.
0.75,
Yep. And then that's not the answer, though. Exactly. This comes out to some small decimal, and you do 1 minus that. And I think this one comes out to like 99.9% chance. But if you think about it, this dude's pretty good at free throws. If he gets 5 free throws, it's extremely likely he'll make one of them. Okay. All right. So that's called the binomial. And that's the second to last thing. There's only one more thing. That happens on Monday. Then we'll review Tuesday and test Wednesday. That's the pace we're on right now. Okay. So Let me give you one more. You go to this restaurant, and there's only a 40% chance you're going to get a table because it's a really popular restaurant. If you go there 5 times, what's the probability you'll get in 3 out of the 5 times? I'll say it again. 40% chance you get into this restaurant on a given day. You walk up, not very likely you get in because it's just so busy and so many reservations. 40% chance. That told you this. And this. 40% you get one, 60% chance you will not get one. Then that's what makes it binomial, because there's only 2 things that can happen. Then there's a C in front. How many times did I try? 5. How many times was I successful? 3. And then the 3, and it has to go somewhere. I was successful 3 times. That goes here. And then that forces this number, because this and this, I don't know if you caught this, have to add up to that. You know what I'm saying? So this must be 2. Raise your hand if you had that one right. Okay, good. What if I said you got in at least 3 times? Then you could do 3, which you already have. Or, means add, do it for 4. Or do it for 5. So this would be 4. And then this number goes here. And then that plus that, this number here, has to make this number. So that has to be a 1. And there. Now that's probability of 3 or 4. And then I could make 5. 5, choose 5. And then this 5 goes here. And then 5 plus that must be 0. And then add them all up. This or this or this. Another way you could have done it is find probability of getting in 2 times or 1 time or 0 times, and then go 1 minus that. But either way, you have to add up a bunch of things this time. Ors mean add. Okay, so let's get to your worksheet. Pause for a second while we find it. Okay, so on this one, problem 1 and 2 kind of refer to the same exact thing. And so we need to do all of problem 1 and 2. And that's going to be a great review by itself. So we're just going to do one more thing. Problem 1 and 2 is basically the chart and then all the questions about it. And then we'll do number 3. And that's it. Just do 1, 2, and 3. All right. A weighted coin has a 65% chance of coming up heads. You toss it 7 times. Set up the formula for finding each of the following. All right. Man, why do they have to do 7? Holy cow. Well, I guess we'll get some practice making this formula. All right, so 0.65 and then 0.35 because that makes a total of 100%, right? And then it shows 0 heads. Then that means there was how many chances? 7. And I got 0. And if it's 0 heads, then that's to the 0. And this must be the 7. And you actually use your calculator. Remember to be smart about these. Like anytime you choose 0, that's just a 1. And anything to the power of 0, that's just a 1. So really, it's just 0.35 to the 7. All right, and once you've got this whole chart filled out nicely, the questions are actually pretty easy. Probability of the head coming up 4 out of 7. Well, that's one of the things on your chart. It's one of the answers that's in the chart. It was this one, 4. And so hopefully you just did that right. It was 7, choose 4, 0.65, 0.35, 0.65 to the 4, and then this must be 3 because it has to add up to 7. So there we go. And you can use a calculator to get the decimal. All right. I do want to do a little bit of number 3. This is those defective problems. Yes, it's possible to do them with the CC over C. But since we're in the context of binomial, I'll show you can do them with binomial. What's the probability there will be no defective bulbs? And that means I can either figure out the probability of 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9, 10, 11. It's one of those deals where I'd have to figure out a ton of things. All right, you can do this with a C. And 2% of them are defective. And that means 98% of them are not defective. And you hopefully should be able to set that thing up. Remember, if you want not something, you can always go 1 minus. All right, there is an answer key also. If you get stuck, you're not a bad person if you check it. It's a really good idea to check it, because then you don't want to get something wrong in your head. You think you're doing it right, and you don't even check. Well, you just stuck it in your head that way, that's the right way to do it. And you're more likely to screw it up later. So take a minute to look at the answer key. Nothing wrong with that. All right, so that's called the binomial. And that's all I have for you for today.